In this video, we'll go over the Steamworks Remote Storage, also known as Steam Cloud Save, as well as setting up Steam data libraries and exactly what a Steam data library is. Before we jump in, we need to cover a few concepts unique to Heathen engineering. These come from Heathen's Systems Core framework, which is the basis of all Heathen assets. The main concept to grasp is that of the scriptable variable. That is, a scriptable object you can define in your asset folder that represents some variable value, be it something primitive like a float, or something complex like a quaternion rotation, or even a custom class. Aside from being defined as a scriptable object and thus easy to reference throughout your game without the need of a singleton system, these scriptable variables are also all serializable, and we have a handy tool for serializing and deserializing them to binary, which makes for nice small files that can't simply be edited in Notepad. As noted, you can create your own custom variable types. So if you had a complex class, say player data, that stored health, name, and who knows what else, you can make a variable for that complex class, assuming that class is serializable. So it's the same sort of rules you'd have if you wanted to make a custom class syncable over a network. How exactly you do that is a bit much for this video, but I'll link example code of doing just that, and you can see other examples in our asset. One more quick note on scriptable variables. These are really powerful ways of storing and using data in your game. Take, for example, player health. As a scriptable variable of type float, doing this not only means you can easily save the value to a file, it also means you have one point in memory that can be referenced across multiple scenes and that has a built-in event that will tell you when it changes. So your health bar, it can read it from here. Your kill player script can read it from here as well. None of them need to know anything about any static classes. None of them need to reference the player object. This makes your code far less interdependent, which means more maintainable and easier to unit test. The merit and value of leveraging scriptable objects is a big topic, so we'll leave it at that and get back to Steam Remote Storage. So you might be wondering what all this has to do with Steam Remote Storage. Simple. Our tool serializes data libraries for you and stores them on Steam's backend. A data library is just a collection of scriptable variables. So if you wanted to, for example, say player data to a file, you'd first create the values that make up your player data as scriptable variables. I'll build out a few here now in the data library itself. So first we create a float for health, a string for player name, let's do an int to represent race, and a bool for gender. We could keep going, but you get the idea. Then we'll reference these together in a Steam data library, so let's make one of those and add them in. Note that we actually need two variables for each field. This represents the variable itself, ergo the current value, and whatever its default is, so that when we make a new file, we can simply call default and have it set the values accordingly. Now before we go further, we'll give this library a prefix. Prefix works a bit like extensions do in Windows, in that we use them to know which library a file belongs to by matching the prefix of the file. So this needs to be unique if you have multiple libraries you're saving. In my case, I'll simply call it chair underscore. So if I save this as Loden Darkstar, then the file name on Steam will be chair underscore Loden Darkstar. The last step is to link this to my Steamworks Remote Storage object. So let's create that on our Game Manager's game object. What this does is help query Steam for files and load them into the proper library. Remote Storage has methods such as refresh data files index, which will fetch all the addresses for all the files the user has access to for this game. You can use those to load a specific file. We of course have helpers to do this for you. Steam data file list, for example, takes a reference to a particular library, along with a prefab prototype that you want to use for each record. You can configure how you want it to display the modified date time, See C#.net toString formatting for date time for details. All of this, of course, is demonstrated in the package, with the working data library already in place. What the Steam data file list does is display a list of all the files for this particular library found on the user's remote storage. The prototype it uses as a record uses the Steam data file record script. This not only helps display the metadata about the file, but also loads the file when activated. When a file is loaded, what we are doing is reading the values for each scriptable variable in the library by name from the binary file. We load those values into the scriptable variables. This means that I can add or remove fields without invalidating the file. We read each field by name and attempt to store it into the scripted variable. Missing fields are simply skipped. So how do you save a file? You simply call save on the data library. It will serialize the values currently stored in the variables to binary and hand them off to Steam for storage. Loading a file is the same. If you want to do it manually, you only need to know the address of the file, ergo its name, which, as noted, you can get from the remote storage script by simply refreshing the index and picking the one you want from the address list. Scripts demonstrating manual use of the library and storage script will be included, as well as scripts demonstrating the creation of and use of a custom scriptable variable. That's it for this time. Next time we'll cover Steam DLC. Thank you.